Hello, students. Had a question about repeated decimals. So something like 1/7 we saw in class. 1/7 turned out to be 0.142857. We did this one in class. And when we did this, we ended up with a repeated remainder. And that was the reason we knew that it would only be 6 digits long, is the remainder repeated. So to illustrate that one more time, 7 goes into 1.000. I'm going to put some zeros down. I may need less. I may need more. I don't know. And so 7 goes in here 0 times. 0 times 7 is 0. Subtract, I get 1. I circle that one in pink, telling myself that is one of my remainders. The first remainder I got was a 1. Bring down. Now I have 10. 7 goes into 10 one time. That's a 7. Subtract leaves me with a 3. My next remainder is a 3. But don't have anything that's repeated yet, so I keep going. Bring down the next one, 30. 7 goes into 30 4 times. 4 times 7, 28. Subtract, I get a 2. Before I bring it down, I circle. Why? Because that's another remainder. So far, I've seen a 1, a 3, and a 2. No match yet. Okay, bring it on down. That's 20. 7 goes into 20 2 times. 2 times 7, 14. Subtract gives me a 6. Unfortunately, still no repeating remainder. Next one coming down would be a 0. 8 times 7 is 56, which gets me as close as I can without going over. And once again, I have a remainder that does not repeat, so I continue. Okay, 7 times 5 is 35. When I subtract, I get a remainder of 5. That remainder has not been shown yet, so I circle it. And then we come back and say, bring it down, gives me a 0. 7 times 7 is 49. Minus equal, give me a 1. Oh, it matches. And so what that tells you is that you have 1, 2, 3, 4, 5, 6 digits in the repetend. That's as many as I have right up here, and I'm done with this problem. Now think about that. When you're dividing by 7, like any number divided by 7, you think about it, it will go in a certain number of times and have some remainders. The remainders have to be less than 7. If you had a remainder of 7, you could just make a whole other group of 7 out of it. So nothing bigger than 7. So that means my only options are 0, 1, 2, 3, 4, 5, or 6. So there are technically 7 remainders possible. But realize if you're going through a division process and you end up hitting right on the nose a 0. Now I'll give you an example of that right next to it here. Okay. So let's say that I did 1.4 and I did 7 divides into 1.4. And again, I may need some zeros here. 7 goes into 1 0 times, right? 0 minus equals 1. Okay, so I have a remainder of 1. Bring the 4 down. 7 goes into 14. 2 times 7 is 14 minus equals 0. I now have a remainder of 0. When I bring the next 0 down, right, I get zeros from that point on. So if you ever get a remainder of 0, your fraction turning into a decimal terminates. This one up here did not. It repeats. So 7 remainders possible is what I have for remainders. But in terms of a repetend, we have to come back and cross 0 out because 0 means it terminates. And if you know something like 1/7, you can look and say, I know it doesn't terminate. So that means there would be a max of 6 remainders possible. And eventually, after you do it long enough, they have to repeat. Sometimes they'll repeat sooner. Let's look at one of those. Let's say we have 3/11ths. So again, maximum of 10 remainders. That'd be like the worst case scenario. 10 remainders. Again, 0 would be a remainder for division, but it won't be a remainder here because I know this one has to repeat. When I do 11 into 3, and I'll put a bunch of zeros here, I don't know how many I'll need. 11 goes into 3, 0 times, leaves me with a 3. What do? Circle it. That's my first remainder. Bring down the next number. Bring it down, gives me 30. 11 into 30 goes in 2 times. 2 times 11 is 22. When I subtract, I get 8. Haven't seen 8 before. Keep going. Okay. Oops, go green again. Bring it down. 8. 11 into 80 goes into 7 times. 7 times 11 is 77. And you get a 3. And this is kind of the beauty of the system. It matched, which means I have 1, 2 that will repeat, and they will keep repeating in that order. There are 2 digits in the repetend, and I'm done. Even though the max was 10, I only needed 2 to make this work. Okay. But what other technique could you use if you were doing this, if you were trying to convert this to a decimal? Think about the beauty of all the 9s. You remember if you had a whole bunch of 9s in the denominator? So if you have an example like 3/11, you could say, hey, I could floff that to get 99. Floff this because I see I multiply by 9 each time, and that gives me 27, and boom, I'm done. Okay, so the power of the 9, don't forget about those 9s. They are really beautiful. What else could it be? You have other things that you could do that divide into some of those big pieces. Like 9s are the biggest one because they're just so quick. If you can make 9s, do it. But yeah, I think that was the biggest piece related to those. As a matter of fact, if you wanted to, you could kind of say something like you could do division, where you actually divide not into a bunch of zeros, but you just keep putting 9s in. And here's why. I'm going to show you why, because I think it's super cool, right? So 7 goes into 9 one time, leaves me a 2. Bring it down, I get 29. That goes in 4 times, which is 28. Bring it down, I get 19, which goes in 2 times, 14. Bring a 5. Next one down is a 9, 59. 8 times 7 is 56. Bring a 4. The next one comes down as a 9. 7 times... Oop, that's a 3. Wah, wah, wah. Sorry about that. That was, you know what? Let me just erase that because that looks horrible. Makes me look like I was just making it up. 39. 5 times 7 is 35. Subtract, I get a 4. Bring this down. 49. 7 is 49. Minus equals 0. So what this really shows, and again, you're kind of wondering, why did you put a bunch of 9s? Well, here's why. What I just showed you is that 7 times 142857 is equal to 999999. That's 6 9s. Why is that so important? Because if I know that fact, I can floff with a really, really big number and get 142857 over 999999. And when it's 6 9s, you know that you get 142857 with a bar over it because the 9s are the repeaters. And that is true indefinitely. And it's really not just that it's 9, it's your base number minus 1. If you want to do decimals in another number base, we wouldn't call them decimals because deci is for 10, but you could do them in such a way that they are fifths, 25ths, 1/25ths. You could do fifths instead of tenths. It would just be base minus 1. So the repeating number in base 5 would be 4s. You'd look for things that are in the 4s. We're in base 10, so we look for 9s. So that is a really cool feature, at least to me, as I go through and do this, as I'm trying to think, well, what would that look like? If you can multiply your number by something to get a bunch of 9s, that tells you exactly how many digits are in the repetend. Exactly. And it even tells you what 1/7 would be in the decimal form. So pretty cool feature. Let me just jump over and make sure that I am getting all the pieces here. Okay, there we are. Oh, and I guess I should say one last time that once you know something like 1/7, you really just know that this is 0.142857, 142857, 142857, and it just keeps going, right? So what I said in class with the bracelet idea is each one of these kind of values, like the 1, the 4, the 2, the 8, the 5, and the 7, each one of those corresponds to a particular fraction starting point. Now they have to go in order, relative size. 1/7 is going to be the smallest of all of these. When you look at all of these digits that you see, the smallest would be the 1. So 1/7 is going to start with a 1, and it's going to be 6 digits long. Next up, 2/7, right? Well, 2/7 has to be twice as big. So if you look over here and you say, well, 1/7 started with 1/4, then 2/7 has to start with 2/8. So what you do is you just come over and find the next digit, in this case, the 2, and you say, well, that is where I would start 2/7. It would still be 6 digits long, but the 1 and the 4 wrap around to the end because it just keeps repeating. Okay. 3/7. Well, that's a little bit less than 1/2. A little bit less than 1/2 would be less than 0.5. 0.5, less than 0.5 would be 0.4 and a 2. So this right here would be the start of 3/7. 4/7 is a little bit over 1/2. So 4/7 would actually start right here. 5/7 would be the next one up. It's going to start with a 7. 5/7, and 6/7 starts with an 8. You pick any of the 8s you want. Pick this one over here, doesn't matter, and you get 6/7. All you're doing is changing the starting point to the order of the digits. That's why we made that bracelet. You just swivel it. Find your starting point and then just read like you're wrapping it around and around and around your wrist. So if I wanted 3/7, I would come over here. I'd start with a 4, 2, and I'd have 4, 2, 5, 4, 2, 8, 5, 7, 1, 4, 2, 8, 5, 7, 1, 4. And that is how that works. All right. Hope that helps. Off you go.